Hello everyone, my name is Denis, and today we will talk about some detective stories. All of them relate to SQL, and all of them require some investigation to find the root cause and then maybe to fix if at that moment there is something to fix. All of them contains a lot of attributes from classic detective story, like suspects, sometimes victims, some process to do this. And in this talk, we will follow all these stories. We will make the whole new investigation, and we'll find the root cause. All of them are different, and despite some of them will look not so usual, yes, I can assure that everything you will see today happened in real life. Okay. Please silence your phones. I have already silenced mine. Yeah. Besides PASS Summit, PASS offers a lot of resources where you can learn something new. 24 hours of PASS, free one-day webinar with really good content. Local user groups. How many of you participated in local user groups? Wow, that's great. In case you are not, I highly encourage you to check if you have local user group and try to come to the meeting. Maybe it will be very good. Okay, SQL Saturday events. This is my favorite one. I'm organizing SQL Saturday in Ukraine, particularly in Kyiv. And I believe that after PASS Summit, this is the biggest driver for SQL community, which moves us forward. Also, we have PASS marathons, PASS virtual groups. And if you want to support PASS as a volunteer, this will be highly appreciated. Okay. This is me. My name is Denis. I came from Ukraine. I worked for an American company in TAP as a data architect. And a few more terms about me. Let's go to our agenda. So first detective story will be about why my query is slow. This is pretty common detective story, yes? And we will check one particular very common root cause of this. Second detective story, where is my database? Well, this one sounds really bad, and yeah, we will see what's there. Detective story 3, file size is not reducing. Yeah, this is why when we're doing shrink, and yes, shrink is not recommended in a lot of cases, but when you need to reduce size, yeah, you need to do shrink anyway. You don't have a lot of choices here at this point. This will be detective story 3. Detective story 4, my CPU burning, but no queries are executing. This one is pretty interesting. So no load, no observed load from the queries, yes, but CPU doing, your computer, your server doing something. Detective story 5, I call it butterfly effect. I don't have much to share right now, but we will look at this on demo. That will be pretty interesting. And the last one, I call it how deep is the rabbit hole. Well, okay. Let's start with the first one. Why my query is slow? Case details. From the user experience, from user viewpoint. Everything is slow. System is not working. Yeah. Technical details. Queries timeouts. Query timeouts. In worst case, query connection timeout. And really, we see long-running queries. Yeah. Before going to the demo, let me remind you the query execution, how SQL Server do this. Connection to server opened. There is an object connection inside SQL Server, which we can check in the view. Then session and request. Request is actually our query, which is currently executing in SQL Server. Yes. Then if query is parallel, it will have several tasks. If query is serial, it will have just single task associated with it. Task need to take a thread from the pool. Yeah. This thread also called worker. And worker can be in 3 states. Running, which means it got all the resources and CPU time and currently executing. Suspended, which means that request waiting for some resource, like it waits to put log on the row. It waits to write data in the transaction log. It waits to pull data from the disk to memory, something, yes? Some kind of wait. And next one, runnable, means that request got a resource which it was waiting for and currently is waiting for CPU time to start execution. Okay. Okay, let's look a bit deeper to the state which calls suspended and to all this workflow. So we have 2 schedulers, which means logical CPUs. We have runnable queue, we have suspended queue, and we have a table users where we have ID and name. So first query came to server, select star from users where name equals code null. We put shared log on this row, yes, and query start executing, yes. Second query came, which tried to update users where name equals code null to name Optimus Prime, yes. Honestly, this is actually a real case, yes. In the US, after first Transformers movie, this guy, Scott Null, decided to change his name to Optimus Prime. Well, yeah, this one sounds really good. But from SQL Server perspective, SQL Server put update log on this row. This means update intention. But then to make actual data modification, he needs to put exclusive log on the row, yes? And at this point, the row already blocked with shared log. So SQL Server put this query to the suspended queue with wait type log mx. Means that this query is waiting for exclusive log. First query finished. Second query can set exclusive log. This is what done right now. And then SQL Server can put this query to runnable queue. Now query is waiting for the for free scheduler to take it and start execution, continue execution. Okay. At this point, update happened. SQL Server remove exclusive log and query finished. So this is a life cycle for the query. Okay. When we need to wait for some blocked resource. Then let's check why my query is slow. Yeah. So I have some secret workload. It's over there. Yes. Oops. What's... Okay. I wanted to show you. I will run this workload. So the query finished. You see? The query executed successfully, and now I'm running additional workload. I'm running some application stuck. Yeah? I'm running some query from SQL Server, from Management Studio, query stuck. Yeah? I'm running another one query with update. So query stuck. All queries are not, maybe looks like they are executing, but they are not. If we will check the requests, and actually if we return to this slide, yeah, I forget to mention one interesting thing. When we start troubleshooting something like this, when something is slow, we are starting from this point, from requests, yes? Then we can go left, we can go right, we can go up to connections, we can go down to the internals of SQL OS, to workers, schedulers, and so on. It depends on the task which way we will follow. But starting point, anyway, requests. Let's do this. I am doing select star from sys dm exec requests, and I'm cross-joining, cross-applying. SQL text to check the query text, yes? For all that queries. SQL handle, T. Here I will put t.text, r.star. And I will filter out current query. not equal ID. So that's it. When I'm doing cross apply, I'm cutting out the system queries. Yes, because they don't have text. I'm showing just user queries. Okay. Let's run this. What we can see here, some queries, yes, they are in suspended state. Oops. They are in suspended state. Okay, let's look what they are waiting for. Yeah. This is also a big indicator for us that queries are waiting for something. Duration is much bigger than CPU time. Yeah. Which means this difference between duration and CPU, wait time, is wait time. Okay. Currently, they are waiting in this wait, log ms or log mix. Okay, let's check what they're waiting for. We have a field, we have an indicator here which is called blocking session ID. Yeah. Let me put it in the beginning of the query to simplify the troubleshooting. Session ID, not blocking session ID. Okay. Oops. So what we can see here, session 70 block session 71 and 73, and session 70 itself blocked by session 65. So currently we do not see this session 65 here. Yes? Let's try to search for it. Let's do auto reply to check the system sessions, but this will not be our case. As you see, we do not have session 65 here. So what does it mean where it was lost? Okay? So when we see something like this, this means that there are no currently executing requests in that session. But session is still open, connection is still open. Yeah? That can happen in several cases. But probably that session holds some logs there. Let's try to evaluate what happened in this there. So we are going up right now from request to sessions and to connections. If session exists, we will find it. Oops. Which ID was there? 65, yes? Here we go. This is my session. By the way, this is always very frequent root cause for this particular case. The query started in Management Studio, yes? Apparently. And the status for this session is sleeping, which actually means that no currently executing requests, but this session can hold logs. This is our case. Now we need to understand what this session is doing or was done previously. If we have trace or extended event session running, we can find that queries, yes, by session ID. But usually we are not running that. And we have one interesting detail here. Let me check. Select star. So now we're going upper to the connections. Connections where session ID equals 65. Okay. This is the information about the physical connection, protocol, host, and all other kind of stuff. But the most interesting information here for us is this most recent SQL handle, which actually means most recent query executed in this session. Wow, that's great. Let's try to find what's happening there. We are doing this using function dmexec SQL text, yes, and passing there the ID. Wow. This is the case. In my Management Studio, I usually use statistics.io off, and yeah, let me go to the session itself. Where is my first workload? This is actual query. Yeah. Let me do it like this. In main management studio, I set it by default. So let me run it again. And let me take the most recent handle from here. Good. Now, this is the case. This is our query. Update user, set cache date, where ID equals something. Now we've got the information about the transaction, and we have enough information to decide, kill this transaction or not. Yes? If it's important, maybe we will allow it to continue. If it's not, we will just kill it. So, kill 65. And this is my application, which is running right now. See, application finished immediately, and all my queries finished as well. Good. So we deal with this root cause. Unfortunately, it's happening too often. Yes, to not noticing this. In most funny situations, it's happening like, why this query is running for a long time, so I will run it and go for lunch. Yeah, in 1 hour it will finish, but other people in company experience some slowness during that time because of the blocking. So it's not a good practice to run such kind of long-running queries during the working day, and here is the way how we can find it. Okay, this is almost an end for this story, but I want to share one more thing here. Sometimes we can get not full information using this approach. Yeah, from sys. Let me close the workload so far. Okay. Let's imagine we have such kind of situation. Yeah, we are running some workload, and we see in the exec request something like this. This is the query which gives us the biggest load. And we see the function which can't run by itself. Yes, something called this function. Maybe this is stored procedure, maybe this is ad hoc query. But at this point, we do not understand the full, we do not see the full picture. And SQL Server 2016 give us pretty interesting approach and new function which called input buffer. Yes. Exec, oops. Input buffer, where we pass session ID. We can pass also request ID, but session ID is enough. So in this case, if I will see this workload again, yeah, this can actually save a lot of time for troubleshooting. I can see not the function call itself, yeah, but I will also see this, the first query ran here, yeah. So here I see these function calls. Sometimes when function passed, I see procedure, but in input buffers, I see the first query came to server, this in the content of input buffer. And in my case, this is actual stored procedure call. So this can help to investigate the root cause. Particularly in this case, in this story, the issue happened on Black Friday, very big load. And the function itself can't be optimized very quickly, yeah? But it used in more than 100 stored procedures. And it's possible, some procedures should not be so precise. Yeah? In some procedures, this function can be changed to a more lightweight function. And using this approach, we grouped by event info, found the biggest impact, and make stubs in that procedure. So workload came down from 100% to 20%, and Black Friday went fine. But without this feature, it will be quite hard to find the solution. We have the BCC input buffer where we can pass one session ID, but this approach is much better. Available starting from SQL 2016. OK. Let me leave this query because it will be useful in future. And we're coming to the second story. Where is my database? OK. Case details. From the user experience, system is not working. Yeah? Technical details. There is really no database on server. Yeah, and in this particular case, client called me and asked if I can make an advice. Sure, of course. And then he asked, do you think SQL Server can delete database by itself? Yeah, well, no. Other way, I will not have a job. Yeah, but our admin said that it was. OK. Let's check what we can do here. Yeah, actually, they have already started restore, but the database was 2.5 terabytes in size, and it took about 2 hours to restore database. And during all that time, system was down. Yeah. So we have checked a lot of things there, and honestly did not find anything in the Windows logs, SQL Server logs, and a lot of other resources. But there is one place in SQL Server which can track such kind of big events. Yes? And this place called default trace. Traces. So there are two data collectors in SQL Server running by default. First one is system health extended event session. Second one is more old default trace. Yeah? Somehow they intersect, but in my experience, extended event system health session usually usually recycle much more frequent. In that case, extended event session system health hold data for 20 minutes, something like this, but default trace hold data for several hours, yeah, maybe even for days. I don't remember. So let's go to the trace and check what we can get from there. Yeah. I will go to the folder. This is actually SQL Server folder. And let's find this default trace. Here we go. Let's take the latest one. Which one is latest? 360 probably, yes. To open it, I need to copy it to different place. Yeah. Let's copy it to our presentation folder. Continue. Here we go. And let's open it with the modern tool, SQL Server Profiler 18, the latest one. OK, let's scroll it down and see what we have here. Alter trace, server memory changed. Let's go further. What is this object altered? Should be fine. Let me know if you will see something interesting here. Oops, what is this? Object deleted. That sounds interesting already. Yeah. I see host name, username here, login name. Oh no, this is SQL telemetry. Probably it's not our case. This is not the guy who can delete database, I hope. OK. What is the time for these events? Start time 6.4. 16:49. We started session about 16:45. Yes. It should be. Did you see this? Where? Up? This one? Oh, yeah. Let's check. Object deleted. Login name. Wow, this is me. Oops. Database name. Yeah, you see, very important database. Okay. And this is also nice. So for event object deleted, object type is DB, database. So let's see what else we can find here. Do you see something interesting? Oh, wow, application name. Here we go. Well, this is not SQL Server anyway. This is Management Studio, which means someone logged into SQL Server and apparently dropped the database. Well, using this information, we have solved this case, but in such case, it's not a good idea to hide the information, but better to share. Yeah. But I hope you will not use this information for with bad intention, yeah. But this is something worth to know, because sometimes this may help you with the investigation. Okay, that was pretty hard case. Let's go to the next one. File size is not reducing. Shrink is pretty extensive operation. It moves the page from the end of the file much more as close as possible to the beginning of the file to reduce the size, and then actually reduce the file's physical file size. It's not good because it causes huge fragmentation. Yes, all operations with data will become more slow. But sometimes when we really need to do shrink, we need to do shrink. Yeah. In one of my cases, situation was following. This space is running out, database file is not shrinking. Data is growing continuously, and approximately there is one data disaster. Only 30 gigabytes was on the disk. Database size 2.5 terabytes, several databases on the disk, and database shrink operation stuck even on 1 megabyte. So we are trying to shrink like 10 gigabytes, not working, 5, 4, 2, 1, then down to 1 megabyte, and it's still not working. Situation is pretty complex. Database is part of availability group. Database indexes are highly fragmented. This is good news, yes, but anyway. And 30 gigabytes free space on the disk. Yeah, and we have only one night trying to fix this like maintenance window. Because tomorrow situation will be much worse. Okay, oops. We will back to the presentation after starting shrink. Yeah. So this is simple. Database called Twitter for shrink. It is 49 gigabytes in size. Where is this? I don't see it. Let me try to refresh. Okay, yeah. I have restored it before the session. You see, I can save 17 gigs. I can save 17 gigs of space on my disk. Yeah. Good. Let's try to do this. Oops. Probably 3.0. I have some workload. Let me run it. Oops. Then I'm trying to shrink. Okay. And you know that in sysdm exec request we have a field percentage complete. Yeah. We can check. So our session with shrink is 67. Let me put it here, 67. And I'm showing percentage complete. How long we should wait for this operation to finish on SQL Server opinion. And I'm I'm showing logical reads in a megabytes format. Each logical read is reading one page from memory. Page is 8 kilobytes. So I multiply it on 8 and divide on 1024. Okay. Let's see what's happening with shrink. Wow, 81% done. Good. But then we are waiting, and these numbers are still the same. Wow. So, but if you will check the reads also still the same. Okay. So what we can do with shrink, we can go back and forth using that views, find what's done there, who is doing something. At this particular case, you see that status is suspended, which is not good anyway. And we will check what does it waiting for. It's waiting for log, and we have blocking session ID 68. This is my session ID 68. Yeah. I'm killing this session, kill 68. So my shrink should be fine right now. In real case, application shut it down to ensure that there are no external connection to the servers. Yes, we're just doing the shrink in this maintenance window. Okay, let's check the shrink again. Let's check the shrink again. What you can see here, percentage is still the same. Yeah. Status is changing from suspending to running. Reads are growing, but percentage complete are still the same. It's still the same, yes? It's not changing. And one more interesting point here, you remember that database is 49 gigabytes in size. We're shrinking it to 40, which means we want to cut down 8 gigs, yeah? And for a long time, I did not think about shrink a lot. I think, well, this is pretty dumb operation. Just put a page from the end of the file and put it at the beginning. But you see that already reads exceeds the size we're shrinking twice. Yeah. So maybe shrink is not so simple. Yeah. Apparently. Let's check. Then I start thinking what can be wrong with shrink. Yeah. All database tables, in that case, were clustered indexes. Yeah, and there were other indexes, so we will not look at the heap. But for index, for index, how much effort SQL Server need to do to move the pages? Root page has pointers to each page on the lower level. That's true for intermediate levels as well, yes? There is no point up, but there is pointer down. And each page on the same level connects with next page pointer and previous page pointer, yes? So if SQL Server moving the root page, nothing changes, yes? It just moves it to the beginning of the file. If SQL Server move intermediate level page, it needs to change pointer on the root page. But this is pretty quick. Okay, and allocation maps. But anyway, let's assume these operations are quick. If SQL Server need to move this page on the leaf level, it will be a bit more operations. It needs to change the pointers on the neighbor pages, yes? And need to change pointers here. So he need to find that page on the higher level. That means some operations, but not much, yes? Actually, that should not be very much. If we will check our shrink again, we will see that percentage is still the same, but we have already read 29 gigs of data, yeah? Let's check what this process is doing. So we can do it like this. If this process was blocked by another transaction, probably this query also trying to put some locks on the data, and this will be, we can expect this, yes, that shrink locking data. Let's see what it's locking. We have a view DM tran logs. Request session ID. Oops. Equal, what is it, 67, yes. Here we can see a lot of resources shrink is blocking, yes, to move data. Currently, we're interested particularly in pages. Let's take one of them and investigate what's inside that page. Maybe we'll find something interesting, maybe not, I don't know. The BCC page. That's nice. Oops. So file name, page name. Now we need to put database ID or name here as well. It is Twitter for shrink. Utilization level 3, the biggest one. Okay, let's check what we see here. This looks like, okay, this is a page which I don't want you to show first, but let's find another one. This page is actually a spoiler to this detective story. Let's find another one. I want to find actually data page, actual data page. Oh, this one was moved? No, okay. What is this? Okay. Last chance, then we will go to another. So, oh, this is not page. Page. Okay, let's try this one. Okay, never mind. This is actually the point where SQL Server stuck, where shrink stacks, particularly in my case. So let's assume that index pages are pretty easy to move. Yes, we need to do more operations, but it's not that bad. But SQL Server have 3 allocation units, which helps it manage data more easy. So when we do update, and our row with variable length is our page space is not enough to hold this row. Let's imagine we have a field varchar 100, and we put their value with 10 characters. Yes, our page is 100% full, and then we update these 10 characters to 90 characters. Page is not enough for this, so SQL Server put the data in another page, and this is another allocation unit which is called row overflow data. Yeah? On the original page, there is a pointer there. Okay, that's fine. We should not have enough situations like this. But when we use varchar max, XML, these blob big data types, var binary max, SQL Server put the data, which overflows 8 kilobytes, to a separate set of pages, separate allocation unit, which is called lob data. Okay. And this is the example of the lob page. This is what my SQL Server is trying to move right now. Yeah? If you can see, here we have page ID. This is our blob page ID. Of course, there is no next and previous page ID. Yeah? And if you will check the content of this page, there is no pointer to the parent page. Yeah? So how SQL Server, I just thought about this, how SQL Server will move this data at all. Yeah? You need to find the pointer in the original table, which pointers to the blob page. Wow, and that can be quite big operation. Yes? And this is what we saw here. Our shrink is still running. If we will check the status will be again 81%. Yeah? And amount of reads is growing because SQL Server moving that blob pages. Well, in my case, let me stop this shrink. It will not finish during this session. Yeah. Yeah. So what have done in my case? When we found that it's stuck on the blobs, there are only two big tables with blobs. Each of them was about 100 gigs. Yeah? So we decided to do radical changes. First of all, we break availability group and put database to simple. Bulk logit will also work in this case, yeah? Because we need to rebuild indexes, which are highly fragmented, but we can't with only 30 gigs disk space. Yeah? We rebuild indexes from small to big to clean some space inside SQL Server database file. After that, we do select into for these big blob tables to allow SQL Server to put them closer to the beginning of the file, okay? Yeah. Then we build indexes on these new tables, drop old tables, and rename the new ones, yeah? So do such kind of operation. Select into is also minimally logged operation, so it was pretty quick with simple or bulk logged recovery model. Then finally shrink database, yeah, because that space at the end was filled by these two tables. Other tables were fine. SQL Server was able to move them, but not these two. Then switch database to full recovery model. Take full database backup to bring it back to full recovery model anyway. And then build availability group again eventually. Yeah? That was out of maintenance window, but all these operations except the last one were done in one night, and this really saved the customer. Yes, the question.
Did you do this with a couple tables, or did you do this with a lot of tables that have blobs?
Two tables. Actually, I found the first table. When it's stuck, do this. Then it's stuck on second one, do this, and then it moved forward very fast.
Were there other blob tables that didn't have the issue?
Others either do not have blobs, or they were pretty small.
Okay.
Yeah. Yes, please.
Do we have to rebuild the index again? Because I believe shrink will affect.
Rebuild index again?
Yes, after the shrink, we have to rebuild again because shrink will affect the index.
Yeah. The question is, should we rebuild index after shrink? For sure, yes. But in this case, it should be done probably over here, or before availability group build, or better after. Yeah. Yeah, this is a very important point. Thank you. Any more questions about this? Okay. Yeah, we need to do this. We need to take backup, because in other way we will not completely back to full. Yeah, we need to do this. Yes. No, because we already have full backup and log backups. Anyway, we will be able to restore to that point of time. Yes, please.
Could you just repeat once again, why should you have to change the recovery mode? Was your log on the same?
Yeah, the question is why we need to change recovery model. Recovery model need to be changed because all these operations, if we rebuild index in full recovery model, it will just put this whole extents of index and put them to the transaction log. Yeah?
Was your log on the same drive?
Yes. That was pretty fast drive. Yeah. Hmm? Drop the index and recreate them after. Do you mean non-clustered indexes? Non-clustered indexes? Well, actually removing clustered index will remove just that head, yeah, but will not remove the data, which is the biggest part of space. In this case, non-clustered indexes were pretty small in comparison with the whole table data. And yeah. Yeah, that's definitely a good idea. Maybe in some case it will help, but this was a bit different. Yeah, that's a good idea anyway. Yes, please. What?
Rebuild index is a single operation. So any column inside the log, we have to see if it's simple or not.
No. When database is full, well, this is out of scope, and this will be, okay, let's continue questions after the talk, because there is a lot of stories remaining. I will answer this one. In full recovery model, when we rebuild index or do other minimally logged operations like bulk insert, select into, SQL Server put those extents completely to the transaction log. If we use simple or bulk logit model, SQL Server just put a mark in the log which extents were changed. So amount of space highly reduced. Yes, amount of space and the time of the operation, because we reduce this I/O. Okay, let's go to the next case. Detective story 4. My CPU is burning, but no queries are executing. So in this case, something should happen on my SQL Server. Let's see my workload. Currently, I have, oops, no, that's not true. But anyway, SQL Server doing something. Yeah. Let me close all these queries. And I will get back to my query with requests. This is what I'm trying to find. What's happening with my SQL Server right now? Something working there. I don't know what. I see that there are no user queries, which is pretty interesting. Yeah. Not equal. SPID. Okay. No queries. So, and then apparently when we check the system queries, we will find by CPU time, disk, and I will put it to the top. CPU time, something like this. We will see that there is one single process called task manager burning my CPU, yeah, which is pretty interesting. We don't see any text here, yeah. We know that this is something system. It even has ID session 33. All session IDs below 50, definitely system. Okay, but what we can do here, case details. From user experience, no explanation, but CPU is something consistently use CPU for 10–20%. And during the peak loads like Black Friday, these become very critical. Yeah. Technical details, you already seen them. System process, which is burning my CPU. Wow. So probably in this case, we should create ticket for Microsoft support. Yeah. And wait. If Black Friday is today, this is not the case. Yeah? We need to do something right now, right here. And we're starting to investigate. So this is session ID 33. We will go to the requests, sessions, connections. We will not find anything there, because actually there is no connection. This is system session fired from this SQL Server engine. But if we will check logs, we will find something interesting here. Equal, what was there? 33? 33. 33, nothing. Oops. Ah, you see? It's finished. Will it start again? Okay. Okay. Okay, but let me show what it was. There was logs on these tables. Select star from tables. What we will see that this query holding logs on, where are they? Okay. something like this. Yeah? You will see something like this. Internal table which has a prefix change tracking, which means change tracking enabled on database and it works as a task manager internal process, system process. What it can do, it can log data, it can do some processor burn, and for this particular case, this process is automatic cleanup. Yeah? If we will check the database, our heavy load database, we will see that here, change tracking configured, retention is 1 minute, yeah? And after cleanup is true. So what we need to do in that particular case, we have maintenance window each night, because during the day there is high workload with sales, at the night there is nothing. And if we'll do it like this, this will remove this CPU load from the working day. Then during the night we can enable this. After 30 minutes, it started, after cleanup started each 30 minutes. After 30 minutes, it will start cleanup, but we are removing all that CPU workload from the workday, yes? And doing it at night. So, and that was really good solution, and it saved a lot of CPU for the client. In peak workloads, that was very, very important. Yes, please. Disabling what?
We purchase cache.
Cross cache. Yeah, by the way, this change tracking has a lot of overheads. It also blow out the query cache with its own plans. It's, yeah. Yes, please.
Is there here where you can see how much time is spent on internals?
How much time spent on what? Actually, no, you need just to explore, and sometimes you can't find anything, sometimes you can find something like this. That internal process use regular logs, but on the internal tables. And you can figure out what's happening there. Hmm? How many seconds it spent? Yeah, this is CPU time, which you see, but this is from the beginning of the request when it was started. Now it's over, that's it.
It's not accumulated
No.
somewhere.
No. Unfortunately. Okay, let's go to the next case. Butterfly, I call it butterfly effect. Case details from user experience. Apparently system becomes slow, something was tuned on the server, but we don't remember what. Yeah? And when you start troubleshooting, you see that max degree of parallelism is set to 1. Well, good. Nice start, by the way. Yeah. Let's do a quick remind what is max degree of parallelism and how SQL Server utilize it. To build the query, to start query, SQL Server need to build query plan. Query plan came to optimizer. First stage called pre-optimization. On this stage, SQL Server simplifies syntax, remove unnecessary parts, load some simple statistics like row count in the table, and search for trivial plan. If trivial plan is not possible, we're going to the next phase, which has a very nice name, phase 0. And at this phase, SQL Server load column statistics, yeah, which shows distribution of the values. Explore plan alternatives, yeah. If it can find good enough plan, it returns transaction processing plan here. Query plan alternatives. Let's look at this simple query which joins data from users table and post table, where user display name like Jon Snow. Logically, we have two options. First, take data from users, then join post. First, take data from post, and then join users. Pretty simple, yeah? Internally, there can be much more options. For each join, we have 3 physical operators. We can do some optimization, so there are much more permutations here. But if we will remove all this stuff and just think about logical permutations, for one table, we will have one option. of getting data. For 2 tables, 2 options. More. For 10 tables, we will have big number of options. So this means factorial complexity for this algorithm. Yes? SQL Server will not use this because it will spend years to find the good query plan, the best query plan. Yes? So in this case, SQL Server I believe it's much more complex inside, but the original idea is dynamic programming. Yeah? Instead of doing something like this and do all the permutations for the table, SQL Server do it like this. He needs join 4 tables, A, B, C, D. Yeah? And our complete search space is n factorial. Yeah? He look at these 4 tables and find that A and B are optimal access paths. We can't start plan from C and D. SQL Server do pruning, yeah, and then do combinations starting from A or starting from B. Then he do these pairs and prune again, yeah, A, B, C, D, and so on and so on. The worst complexity will be exponential, but usually it's much more. It depends on how aggressive it prune the search space. Yes, it gives us query plan pretty quick. But the main idea here, we are not looking at all possible query plans. And it's possible to miss the best one for this particular case. OK. Then if plan was not found on phase 0, we're going to phase 1. Here, SQL Server apply next set of rules and estimate parallel plan. Yeah? Based on 2 parameters, max degree of parallelism, which shows how many cores SQL Server can use for this particular query. Cost threshold for parallelism. This is the value based on which SQL Server decide to go with parallel plan branch or just use serial. Yes? If plan which came here is cost of plan which came to this phase lower than cost threshold for parallelism, we are still use only serial plan. No, we are considering parallel plan. If it's bigger, if it's lower, we are not considering parallel plan. If it's bigger, we are considering parallel plan. OK, never mind. Maybe SQL Server will return query plan here. If not, we are going to the last stage, which called phase 2. After this phase, we will get query plan anyway, and we will get the plan after in 4 conditions. First one, SQL Server do all operations, permutations he wanted. Second, it found good enough plan with good enough cost. Third is timeout. SQL Server decided not to continue compilation, but just return the best plan he have right now. And the last one, not enough memory. This is the worst one. It means that optimizer does not have enough memory to search through plan alternatives. Yes? So we remind this. We found how important max degree of parallelism is, and let's look to the queries. We have few of them. Sometimes our parallelism is good, yeah, and the parallel query will be better than non-parallel. Sometimes parallelism can be bad. In this case, parallel query will be worse than serial. Yes. Oops. Oh, I need to use SQL Server 2019 here. Let me switch to it. There is in my notes. Switch to 19. Good. So in this case, you see that query plan. First one is parallel. The first one is serial. Second one is parallel. And in both cases, here, first query execution, 1.5 seconds. Second, 1.8, and much more CPU time spent. First plan is serial. Second one is parallel. Yes? In first case, it works vice versa. First one, 3 seconds. Second one, 800 milliseconds. In this case, parallel plan is better. Yeah? But let's check another situation. This is pretty interesting. Yeah? Let me discard results after execution. And this is what I call butterfly effect. in the case which I wanted to share, so max.dop was set to 1. That was found very quickly. And we found that query execution with max.dop 8, this is recommended value for the client's amount of cores, is much, much faster. Yeah? Let's pretend the first query. The first query is about, maybe max.dop 1 is about 10 minutes to execute. Max.dop 8 is about 1 second to execute. Yeah? Let me show you the query plan for both cases. This is the first one. You see, 2 seconds. Second one, a bit worse. But let's pretend it's much worse. Yeah? But when we will look at the query plans, do you see? That's interesting. Both query plans are not parallel. They are different, but they are not parallel. The only one thing changed between these two query runs is max degree of parallelism. For first, it's 1. For second, it's 8. Yeah? Wow, that's pretty interesting. So in that case, it was very dangerous to suggest client to use max.dop 8 because for other queries, it may not work. Yeah? Why this happened? Remember that phase 1, when SQL Server make a decision to go with parallel plan or serial plan. If he built parallel plan, he built 2 branches together to decide which one is better eventually. Yeah? So he spent time here, spent time here. If we use max degree of parallelism 1, SQL Server will remove this branch and use this amount of permutations here to check more options for query plan. And in some cases, in mostly cases, all cases, it will be better. But in some cases, less amount of operations will give you better query plan. Yeah? This is paradox, but this is what happened to me. So this plan, parallel plan, is 9, have cost of 9. This plan have cost of, what is this? 7.5. Yeah? In another situation, it can be different. This one is 7. This one is 7.5. Well, not a bit different. But anyway, this is what I call butterfly effect. This is something we change, and it changed not just parallelism of the plan, but changed a lot of things. It changed the query plan without changing parallelism at all. This is very interesting. And for this case, it's good to check other long-running queries, what will be beneficial for them, max degree 1 or max degree of parallelism 8. And then you will decide which option set on the server level and which option set on the query level. That would be the best decision for such kind of situation. Okay, and now we are moving to the detective story 6. I believe we still have time for it. How deep is the rabbit hole? Case details. From the user perspective, application becomes slow. Well, apparently, and this is coming from time to time. In 1 minute or 1 hour, the same operation will become fast. Yes? From technical perspective, query execution is really slow. When you run this query in Management Studio, it's very, very fast. Okay. The root cause of this is parameter sniffing. This is the default behavior of SQL Server for stored procedure execution and for parameterized queries execution. It works like this. We execute stored procedure, and SQL Server compile the query with the parameter user ID equal 1, and put this plan to the query cache, to the plan cache. Second, procedure execution. Check if plan is already in the cache. Use it without compilation of new plan, which means if for user 1 you have 1 row in the table, for user 22 you will have 1 million of the table, first plan will not be efficient for second query. Yes? And this is where parameter sniffing become an issue. When you have parameter sniffing and when you have data skew, yeah, depend on the parameter. Okay, the same story for the parameterized query. When you execute some kind of this from entity framework or from application code, SQL Server translated to the call of SP execute SQL procedure. And actually, this is almost the same as a regular storage procedure. It caches the plan and reuse it, even if it's not very efficient. Yes? Well, dynamic SQL solves this problem, but bring more problems. In case of dynamic SQL, SQL handle calculates on all this text, yes? And each small change to it, like parameter 1 and 22, will force SQL Server to compile a new plan. Only when text is completely the same, we can reuse the query plan, like this. OK, now we're going to the demo, and we will check how deep can be the rabbit hole. So first of all, we will clean the cache. OK, second, we will track the data. I will use Profiler, but I can't recommend using it in production. I'm usually using extended events. Using Profiler right now to make this quicker. So I'm starting new trace. The same can be done with extended events. Tuning template. And I will choose few more columns. I will need CPU time. I will need logical reads. That's fine for me. So I'm running the trace. OK, let's go to the workload. I'm running some workload which executes storage. In this case, it executes some query on SQL Server side. Yeah. It takes a while. It compiles the query plan. It executes the query. Yeah. This query is pretty slow, of course. And second run will be faster. And then we will run it with different parameter. Yeah. Of course, we get parameter sniffing here. The query is very slow, as we think, 600 milliseconds. Yeah. So we're trying to troubleshoot it. We copy this query from the profiler and run it from Management Studio. Database Stack Overflow. Let's run this query. And you see this query is pretty fast. It's not about 600 milliseconds. It's less than 1 millisecond. Good. Let's check the query plan. So there can be different situations, but for us, a very good indicator is this. If there are any kind of weights like logs or something else, our duration will be much higher than CPU. In this case, CPU is higher, which means we have parallel query, and probably there are no logs or weights. Yeah? If we see something like this, the most probable reason of this happening that we've got different query plans. Yes? So the querying application is still slow, as you see. And we're going to the analysis. We're going to check the query plan for queries related to our execution. We are getting through exact query stats. OK. Let's find this. And you see, really, we have two query plans for our query pattern. Let's try to check them. This is good one. Yeah. Let me save it as a good plan. Good plan. And this second is the bad one. Yeah. Wow, this one is parallel. It's huge. I will not save it. Good enough, good plan is fine. But I will compare two query plans to find the difference. They're completely different. But when we will compare the properties, yeah, we will find that one of them was compiled with 2014 year, and second one compiled with 2008. Yeah? So they're different. We've got parameter sniffing problem. This explains why query is slow. First run an application was with 2014, then we run it from application with 2008, and it is slow. But there is no explanation so far why in Management Studio is very fast. It's very fast, yeah? The explanation is here. When SQL Server compile the query plan, it built this plan handle. And in that handle, few more parameters except SQL text used. One of these parameters is set options. Yeah? And when we will compare the options, we will see that one query plan has arithboard true and second query plan has arithboard false. What does this mean for us? Historically, Entity Framework and ADO.NET library use arithboard parameter set to off. Management Studio historically used this parameter set to on. This is connection set option. What we can do in this case, we can change set in the Management Studio, but I will not recommend doing this. We can change this option on database level, then it will override the connection option. I will also not recommend to use this, because someday you will forget about this situation, yeah, and there will be some puzzles which you should not have, yeah. I just, yeah. The best option here, just to remember about this behavior and use it during your troubleshooting. If you see something like this, you have two different plans, just set arithboard off in your Management Studio and run the query again to get the exact query plan you are getting from the application. Yes? Oops. Let me run this query again. OK, but what we can do here, we have our plan. Yeah? We can now set option arithboard to off. Set arithboard off. Here we go. Now we should get the query plan which we have in the application, yes? Oops. It's fast. Yeah? It's not about 600 milliseconds. Well, maybe query plan cache was cleaned, yes, already. And we do not have that original query plan. Let's run the application again, and it is still slow. Yeah, it's not immediate, it's about 600 milliseconds. So what we have right now, let's check the query plan cache. Wow. 3 query plans. This is a puzzle. This is nice. And right now, we need to go deeper into the rabbit hole. Yeah? This is the purpose of this talk. We're going to the deep query cache analysis. Here, we will get 3 query plan handles, and we'll compare them. What's different in the attributes? So, where is this? SQL handle, plan handle. Let me copy these 3. I'm copying them here. And I will use function which called dmexec query plan attributes to investigate what's different for these 2 query plans. Yeah? This is my main instrument here. So, as you can see, besides send options, there are a lot of other attributes which make value here. They are used in the algorithm for building plan handle in SQL Server. So, what we can see here, set options 251, this is a bit mask. Probably one of these queries, this is application query. This is our query from Management Studio when we set arithboard off. Yeah? This is our original query from Management Studio. Well, what's else different? Do you see? What else is different between these query plans? User ID, yes, great. So, user ID for first 2 queries is 1. Oh, these probably are our Management Studio queries. But application used this one. Wow, this is interesting. So, user ID can be part of our problem, yeah? And this is our query. This is it. We found we are connecting with my Windows account to this computer in Management Studio, and application use different user. It used this one. Here we go. User ID SO test. Yeah. This is the explanation. Now, even if you are thinking you are going very deep, you can go even deeper. You can check more things. Maybe you will find that it's not about user ID, it's more about user IDs, users who own different schemas. Yeah? Maybe you will find that this works for ad hoc queries, but this will not work for stored procedures, some different mechanism, maybe something more. But I believe this will be very interesting investigation and very interesting story. And I will hope to hear your stories next year. Thank you.